Welcome to VVork. This is the continuation of a video series in which we are discussing containers, Docker, Kubernetes, PKS, and more with Marc Alumbaugh. In this video, Marc's going to compare and contrast virtual machines and containers. Let's get started.
Well, why do I want to run containers? Why? If you look at what you have today, I think we would all agree that virtual machines are, this one absolutely wonderful thing. If you go back to, many moons ago, a decade plus ago, we were all trying to do slipstreams or ghosting images, to get stuff on our bare metal hardware. Virtualization is certainly, I think most of us would agree, has been a real saving grace for us, is to be able to do that virtualization. The reason we're having so much workloads going on is it's all about this piece up here. It's about the application. The reality is we don't really care about deploying a whole bunch of operating systems. The operating system is a necessary evil because that's where our application runs on. And our application has this part down here called the application dependencies. And that's where things start to get complicated, okay? Certainly this box up here, which represents your virtual machine running the operating system with the appropriate application dependencies, and then in turn, my application. This VM, we can move anywhere. Why can we move it anywhere? Is because we've installed some type of hypervisor down here, and I'll just go ahead and say, from our perspective, hopefully you're installing ESXi, and it gives you portability of that big red box. So that red box, I could move anywhere. I've got features like high availability. I've got DRS that are helping me. I've got my portability using things like Site Recovery Manager to make sure that I've got, a business continuity and disaster recovery plan. Everything seems like it's going pretty good. However, this is where things start to get a little bit more challenging, is my application to its matching dependencies could start to get complicated. Do I necessarily always do some type of one-to-one relationship to each application that I deploy to its own unique operating system? Because maybe if I put two applications on the same host OS, I'm getting myself into this problem of application one needs a particular version of some, let's say, .NET dependency or Java version, but application two needs a different one. What ends up doing every time we add a new red box here for an application to run, we end up doing a lot of day two work. We get our base operating system, we spin it up typically from a template, and then we do this, the VM's been deployed, and we say, okay, what do I need to run this application? And we start doing add, and add. Let's set that aside for a second and see another way to do it. And what's another way to do this is we come over on the right side here, and this abstraction level that we have sitting down here, this abstraction level that I just put this blue circle around, why don't we take the benefits that we've learned from core virtualization, and is there a way that we can apply that up here between our application and where we're running the application at? And the answer is yes. It's your container. This is what the whole container paradigm is bringing to the table. we're actually moving the application dependencies up into the container. And we're actually now taking this orange box here, and we're turning this orange box into this new unit of portability. We still need down at the bottom down here a container OS, host OS down here, in order to run our application on top of something. We still get our ubiquitous VM portability that corresponds to this here. This is still my VM sitting up here, but in my VM, I'm going to have my container running. And you're going to have the ability to run multiple containers on a single container OS. So you still have the, what do I want to say? How big do you make your virtual machine today? Do you make a virtual machine with 2 CPUs and let's say 4 gigabytes of RAM, or 4 CPUs, vCPUs, and 16 gigabytes of RAM? That sizing equation still goes on when you go to containers. This container OS and the thing that's sitting in the box is still going to have the virtual machine configuration to say how much CPU, how much RAM, how much disk do I want to give it. And in turn, that's going to be how we're going to end up sizing our containers as to how many containers we can run in an individual container OS.
So, Mark, a couple of clarifying questions. If we can go back
Sure.
to that slide real quickly. So, would a container have to run within a virtual machine?
It doesn't have to. That container OS that I'm pointing to here, this could be sitting on bare metal. It could be sitting on bare metal. It's matching problems if you do that. And some customers have some things that they say, okay, listen, I'm going to put my runtime engine for my container on bare metal.
Right. So running containers within a virtual machine is certainly a natural approach for VMware to adopt. But what is it about running containers within VMs that's going to be useful for customers?
Well, let's think about that. The benefits that we have today in running a virtual machine. There's what was the latest thing, the meltdown Spectre and the meltdown,
the latest
help
nasty.
me out. We had the meltdown and Scepter, Spectre, whatever it was, hack or virus that came out. And remember, we raced through and we switched off hyperthreading. Eventually, people are saying, okay, listen, there's going to be new firmware that if you apply this appropriate firmware on the base hardware, we've got things to mitigate that virus or that vulnerability. Well, if you're running all of this bare metal, if you're running all of this directly on the hardware beneath it, you're going to have to take an outage to do that. If it was a virtual machine, I could just vMotion that virtual machine to another ESX host, put the host into maintenance mode, go about doing my patching, my fixing, take it out of maintenance mode. Same thing, think about if you have a failure. Maybe that physical server, the power supplies went crazy, it croaked the physical server. Same paradigm exists inside here. If we were running this in some type of virtualization environment, your HA would kick in, restart it, and move it over. So your outage would be, let's say within 5 minutes, we would be back operational, where if you're running bare metal, you're going to have to get the bare metal fixed.
Yeah. Okay. Another question, or I don't know if this is a question so much as a comment, but When I first started hearing about containers, one of the things that I heard people say again and again is that containers had the advantage of being lighter weight because the container does not have its own copy of the underlying operating system. That's better, some people said. And that always threw me off a bit because I know that at least in the VMware world, we certainly do have a heavier load within the virtual machines because each virtual machine has its own operating system. But VMware, vSphere, ESXi, and so forth come with a number of advanced memory management mechanisms to deal with the memory load. And in the hosts that I see out there in the world, looking at my customers' environments, they have more than enough CPU cycles to go around. So I never quite got the excitement about lightweight containers. So as I've studied containers more over the last year or so, it seems to me that the lightweight aspect of containers isn't the super big deal, but rather some of the automation and orchestration that we can do around them. Does that sound about right?
I would agree with that. I would agree with that. They do boot faster. They are lighter weight. Is it something that is I'm all excited about? Not really. It's just a benefit that comes along with as you switch over to container architecture.
In the next video, Mark will discuss the traditional monolithic application model versus microservices. Join us in the next video to learn more.